Okay, so today we're going to learn about quadratic identities. So if two quadratic expressions are equal, then all the coefficients, all the matching coefficients are equal. So the coefficient of x squared will be coefficient of the x squared on the other side. The coefficient of x will be equal to coefficient of x on the right side, and they will all be equal. Okay, A equal to capital A, B equal to capital B, C equal to capital C. So we'll do an example. So if these two quadratic expressions are equal, then find the values of A, B, and C. So all you have to do is just go A equal to 6, because this A equal to this 6, B equal to 2, because this B equal to this 2, and then C equal to -3. Okay, so that's a very simple example. Now let's look at a harder one where they don't look very similar, right? They look very different. So how do I make them look the same? I have to expand it. So let's try expanding. Okay, so we're going to expand this. So first we expand the first bracket. So we get ax squared plus ax. We expand the first. The second one, no change. And the last one, we go cx times, c times x is cx. C times 1 is c. And then what you need to do is to bring these two x squared terms together, which is a plus b in bracket x squared. So I factorize out the x squared from the two x squared terms. And then you're going to bring these two together and write plus a plus c x. And finally, you got the constant term. All right, so you write it like this, and we're going to write it in the form of, so this is going to be x squared plus 2x minus 2, okay? Actually, I should use the symbol identically equal. What does identically equal means? That they're equal for all values of x. So let me write this statement, identically equal means equal for all values of x. Okay? All right, good. Now, what are we trying to do here? I'm going to match things. So before I match things, there's a 1 in front of x squared. And then what we're going to do is to match the a plus b with the 1, right? So we've got one equation, which is a plus b equal to 1, which we'll call it equation 1. And then we're going to match the coefficient of x with x there. So with that means we can write a plus c equal to 2. I don't know why I put 1 there, sorry. Oops. Equal to 1, this is equal to 2. So we'll call that equation 2. Yep. And then finally we match the coefficient of, where's the highlighter? Okay, so we've got another color. Let's use green. C will be equal to this -2. Okay, so we can write C equal to -2. So we've got 3 equations, out of which we've already found C, right? So once we found C, I could use it to find A in the second equation. So therefore, A plus C is 2. Because C is -2, I could work out what A is. So what's A equal to? A will be 4. Okay, so we've got A, we've got C. Now what else do we have to find? We're going to find B. So we're going to find B. So to find B, we know what A is. So we're going to use the first equation, A plus B equal to 1. Because A is equal to 4, we're going to change it to 4. 4 plus B equal to 1. So what's B equal to? -3. Okay, so we found all 3 values. So that's how you do it. Okay? So it's pretty straightforward. Writing the form. Yeah, so in that case, what you need to do, you're going to write x squared plus 2x minus 2 can now be written in the form a, which is 4, x bracket x plus 1, plus b, which is negative 3. So because it's negative 3, you get rid of the plus, which is negative 3 x squared, and then plus c, c is negative 2. So negative 2 bracket x plus 1. Any question? So I have written a quadratic expression into a different quadratic expression. That's called, and we use the method of comparing coefficients. Yeah? All right, any question from there? Very easy. Try the next one. Next one is exactly the same. So I match the x squared coefficient with the x squared coefficient, x coefficient with the x, and the constant term with the constant term. All right, all makes sense? Can you try the next one? All right, next one, do the same thing. N squared equal, identity equal to a n minus 3 squared, and you need to expand. Do that. Have a try. Expand. Okay, have a try. I think you will all get it right. Say again. Okay, I'm going to show you how to do that. Let's do that now. So you need to use what we call the perfect square formula. First, ignore the a and expand what's inside n squared minus 6n plus 9, the perfect square formula, and then expand the a last. So now you're going to go 1, 2, 3, 1, 2, like that, and go an squared minus 6an plus 9a. Be careful with your a, make sure it doesn't look like a 9. Okay, otherwise it gets confusing. And b does bn minus 3b plus c. Okay, we got this. And then what you need to do is to group the n squared term together. There's only one n squared term. However, there are two n terms. Put them next to each other. So make sure you factorize it out. So put a plus bracket n. And what you need to do is just whatever this is, negative 6a. So write negative 6a below and the plus b. Does that make sense? Okay, like that. Always put a plus in front of bracket because otherwise give you a wrong result. And finally, we got all the constant term at the end. So we got the 9a, got the minus 3b plus c. Okay, so I'm ready to match coefficients. Okay, we're going to match things together. That's the fun part, is to match things. Okay, so how do I match things? There's only one term, but there's 3 terms on the right, right? So that's your coefficient of, so there's 3 groups. There's the a in front of n squared. There's the this expression in terms of n, and also you have the constant term. Okay, that's together. And then you're going to match it with just one term. So what I do is I write n squared, but put a 1 in front. But it's going to be a 0n because it doesn't have an n term. Write 0n and the plus a 0. Okay, if it doesn't have the term, put a 0 in front of that term. And now we have the 3 matching pairs. What are the 3 matching pairs? So I'm going to get the highlighter to show you. The highlighter will tell you that A is 1. That's easy. And what's the other bit? The green, let's use purple with the 0, right? And then finally we got the, maybe, any other highlighter? Maybe I'll try a, no, that's okay. All right, good. All right, does that make sense? So you have 3 equations. Set up 3 equations. Maybe have the color to help you. 3. Okay, let's look at the 3 colors. So the first color will tell you A is going to be 1, right? A is 1. The next color will tell you negative 6a plus b equal to 0. That's equation 2. And finally, we got 9a minus 3b plus c also equal to 0. So we solve them simultaneously. But in fact, it's very easy. Because I know the A value, I could substitute into the equation 2 to work out the B value. And once I know the A and B, I could substitute into A and B to find the C value. Yes? Let's do that right now. So we can substitute 1 in here. So we end up getting negative 6A times by A plus B, right? Equal to 0. So B equal to 6. All right? And then after that, so basically this is solved, so I'm going to circle it. If it's solved, so we've got this one, we've got this one, we need to get the C value. So how do I get the C value? Substitute 1 into A, substitute 6 into B, and we're going to work out C. Alright, so what do we have? 9 minus 18 is plus C, which means that negative 9 plus C is 0. C is 9. Alright, any question? So, okay, good. So we've got negative 9. Okay, yep. And then what do we do? Make sure we write it in this form. Therefore, n squared can be now written in the form of n minus 3 squared, and then 6 n minus 3 plus 9. Alright, the question's done. So you should be able to do the first 9 questions of the textbook, because they are all like that. Yeah? Alright, hopefully it's all straightforward for you. Yes? And then we'll do the next example, you can do the work. So this part is just long, but they're not difficult. It's quite easy, but just long. Alright, hopefully you're ready. We're going to move on. Okay, let's move on to the next page. Alright, let's get ready. So this is a little bit different. We're going to find the equation of a parabola that passes through all 3 points. So basically, you don't have to draw it. What it will look like is negative 1, negative 3, 0, 3, and then 2, 21. Right? So you're going to find a parabola that passes through all these 3 points. So maybe it's look like this. And you're going to find the equation. And there's a very easy way to do that. To do so, all you have to do is start with the equation of the parabola, which is the most general form. And you need to work out what A is, work out what B is, work out what C is. And how do I do that? By using these 3 points. So if the parabola passes through these points, it will satisfy the equation. That means I could substitute negative 1, negative 3 into the formula, which you will get negative 3 equal A times negative 1 squared plus B times negative 1 plus C. Does that make sense? And if you simplify it, you get A minus B plus C is negative 3. Equation 1. So again, we're going to use simultaneous equation. It gets used in a lot of contexts. And then we'll do another one. We're going to substitute 0, 3 into this formula. So we substitute 0 into x, 3 into y. So A times 0 squared plus B times 0 plus C. But luckily, we just get C equal to 3. We don't have to do anything. But we call it number 2. Okay? And then finally, we're going to substitute 221 into the formula. So write 21. So 221 into the formula above. So you get 21 equal to A 2 squared plus B times 2 plus C, which you will simplify to be 4A plus B 2B plus C equal to 21. Alright, we got 3 equations. Okay? Let's summarize this again. So we got the 3 equations. Let's write them down again. So write A minus B plus C. A minus B plus C equal negative 3. And then C is negative, C is 3. And then you also have 4A plus 2B plus C is 21. Okay, 1, 2, 3. Alright, so we're going to solve them simultaneously. How do we solve simultaneously? Start off with the easiest one, which is the 3C equal to negative 3. So we're going to substitute that into equation 1 and 2. So let's substitute that. So if I substitute C to... Oh, normal 3. Yeah, you're right. Sorry. So thank you. Okay, good. So we rub this off. So right, 3. Okay, we substitute that into above. So we get A minus B. Substitute C by 3 gets plus 3 equal to negative 3, right? And you end up getting A minus B equal to negative 6. Yep. Okay, that's 5. That's equation 4. And then we'll also substitute that into equation 3 as well. So we're going to go 4A plus 2B, and C is plus 3 again. So 4A plus 2B equal to 18. Divide everything by 2. And you get 2A plus B equal to 9. Alright, so equation 5. Yep. So we're going to highlight these two equations. So I'm going to use a different highlighter this time. Maybe use green. So I'm going to use this one and this one. I'll solve them simultaneously for A and B. Yep. Alright, let's solve them simultaneously. So we get A minus B equal to negative 6, 4. 2A plus B equal to 9, 5. So how do we solve them? We can just add them together. Let's add them. 4 plus 5. If we add them, what do we get? A plus 2A is 3A, but the negative B and B gets cancelled, right? That get cancelled and equal to negative positive 3, which is just 3. And once we get that, A will be 1. And once we get A, we can substitute that into equation maybe 5. And then we can work out B. So we get 2 times 1 plus B equal to 9, B equal to 7. We found it. So we've got A is 1, B is 7, C is 3. So what's the equation of the parabola? Therefore, the equation of parabola is y equal to x squared plus 7x plus 3. This parabola will pass through all 3 points I have just mentioned to you. Alright, all done? Pretty straightforward, but very long. Long and a lot of work, but straightforward. So you need to spend the time doing the exercise today to master these concepts. So you do exercise 9.4 today. The question you will do is 3, 4, 7, 8, 9, 10 ACE. Okay? Start with that now. Go. All right.